So we're going to begin the lesson 3 notes, and the first thing we want to talk about is the different types of plate boundaries. And we're just going to take a look at a few of these with our little simulator here. Okay, so what we have is a way that we can crush plates together, pull them apart, do what we need to do. And the first thing we're going to have is a continental plate and a continental plate, and we're going to crush them together. Okay. Now, what forms do you think? Is it going to be one big mountain or what? Here's what happens. You can see the plate getting thicker and thicker. And what forms at the top? This is many mountains. This is called a mountain range. Okay. This might be similar to the Himalayan mountains. Okay, it's not just one big mountain, it's many mountains, and the plate gets thicker. So this is a continental plate and a continental plate. This is what we actually see on the surface of the earth. This is the Himalayan mountains, and it looks very similar to what that simulation was showing us. Okay, just endless little mountain. And when you see them like this, you start seeing them as little wrinkles in that plate as it crashes together. Now the Indian plate is crashing into the Asian plate. And so as this India plate crushes up into China, basically, the Himalayan mountain, Mount Everest is in here, a lot of the tallest mountains in the world are right in this region as these plates crumple up together. Okay? So if you want to see it one more time, these plates just keep pushing together, and these mountains can't do anything but grow higher and higher. Okay, because this is still happening in the Himalayas, Mount Everest, let's say this is Mount Everest right here, Mount Everest gets about an inch taller every year. Doesn't sound like much, but over many, many years, 1,000 years, that's quite a lot of growth that experiences. This simulation was over 35 million years. Okay, so that's the first type of plate boundary. And in our notes, what we have is convergent plate boundaries where, well, what are they? This is where plates collide together. And now what happens depends on what types of plates are colliding. So the first example, what I just showed you, is continental-continental. Okay, and as the India-Australian plate crashes into the Eurasian plate, you have the Himalayas growing up. In essence, this is mountain building. So plates push together and they pile up. So you have a continental-continental collision. This is convergent plate boundaries. That word is going to be important, so maybe circle it, star it, everything else, because that word means to collide together. And when you have a continental-continental, it's mountains that are built. Up next, we have continental-oceanic collision. So let's take a look at that on our simulator. On one side, we have a continental plate. On the other side, an oceanic plate. Now, before we crash them together, I want you to take a look at the density. So the density of the continental plate. You know, it's dense, but now here's the density of the oceanic plate. It's even more dense. Less dense, more dense. Less dense. So the one that is more dense is going to do something kind of predictable. Here it goes. Okay, now we're 14 million years in. This oceanic plate has pushed underneath, but maybe you can see something happening here. Okay, maybe these little bubbles mean something. Let's go a little bit longer. What's forming on the surface there? Okay, these are mountains called volcanoes. Now we learn a lot more about them later, but the volcanoes are powered by these little bubbles or whatever it is that you see here. What you need to know is that this oceanic crust, as it's going under, there's a little bit of water going with it, and there's a lot of dead plants and animals in there too. And as those dead plants, animals, and water get deeper inside of the earth, they start to evaporate, they start to boil, they start to cook, burn. And that gas can't stay in the earth. It can't just pile up more and more gas inside of the earth, so it has to rise up. And that rising up ends up being volcanoes. All the volcanism we see is where these plates are getting pushed down like this. This is subduction, which is a word in our notes we'll see here in just a second. Okay, this is the Alaskan island chain. The Pacific plate is getting pushed under right here, and so all of these volcanoes, these red dots, are forming because of what we're seeing here in the simulation. In our notes, this is a continental oceanic collision. Okay, in the picture I included, maybe you want to put a big old arrow right here to show that this is moving downward like this. And the higher density of the oceanic plate makes it subduct. And this is a new word that I expect you to know. Subduction, subduct, under the lighter continental plate. That's the first part. So it's more dense, so it pushes underneath. Now the second part has to do with this little vent you see here in the volcano. The second part says, the melting, boiling, and burning of the water and organic matter rises to the surface and powers volcanoes. So all the water that gets pulled down, all the dead organic matter, sedimentary rocks that are full of fossils and whatever else, anything that can boil or burn will turn into a gas and then power volcanoes after that. That covers the two types of collisions we will talk about. So these are to converge. Now up next we have to diverge, where plates are diverging. Okay? Divergent means to pull apart. And this word is important too. Divergent, plates are pulling apart. We're going to see in the simulator what happens here with a continental divergent boundary. So we have continental. If we pull these apart, what has to form in the middle? I want you to think. Do you think more continental plate is going to form? Is it going to be oceanic plate? Is nothing going to form? Pause for a second and just think. What's going to form there? Okay, slowly I'm going to pull this apart. And slowly what we see forming in the middle as these plates diverge from each other. Okay, now this is many millions of years going by right now. This is brand new oceanic plate. Now we just went through 15 million years. I went pretty slow at first. When it's still just continental plate pulling apart, something special forms in the middle. In the notes, here's the picture I have for you. Okay, these blocks slide apart, and this landform is called a rift valley. Okay, the plates separate and they form a rift valley. So now here we are in Africa for a second, and if we zoom out, here we are. Africa's really big. Now this is called the Horn of Africa. If you ever hear that term, this is the Horn of Africa. And if you zoom in, right through here, you can kind of see it way zoomed out from here. There's something going on. Okay? This is called the Great Rift Valley. And what's happening is that the Horn of Africa here, this continental plate is moving this direction, while the other plate isn't moving that direction. Maybe it's moving more slowly or something else. Anyway, this part is getting ripped apart, just like we're seeing in our simulation. Okay? It's getting slowly ripped apart, and what we have then is landforms like these, where it's slowly, the continental plate is getting thinner and thinner and thinner. Sounds kind of cool, except people live there and they're seeing their water disappear because it's getting so warm, because lava is getting so close to the surface. Eventually, the plates will be so far apart, there'll be volcanoes and new lava, and eventually, and we're talking a long time from now, this rift valley will get so low that the ocean will cover it and you'll have new ocean plate here. So that is a rift valley. Now the last type of boundary we're going to talk about is an oceanic divergent boundary. Okay, so this is a continental pulling apart. Eventually you have two ocean plates that are pulling apart. What you end up with is new ocean plates. We call that a mid-ocean ridge. Here's what the mid-ocean ridge looks like on Google Earth. So if we zoom out from Africa, go around the Earth here, in between South America and Africa, there's all these little markings. Right in the middle, this is the mid-ocean ridge. So the Atlantic Ocean hasn't always been the size it is. It starts down here, very much near Antarctica, and if we follow it, zoom out and follow it, it goes all the way past Africa, past the Americas, past Europe, and it actually breaks the surface here in what we call Iceland. And Iceland's got a lot of renewable power because there's so much magma as this country gets pulled apart. This side of the country is going this way, that side of the country is going that way, and in the middle you can see that there are gaps where over time lava has flowed and filled it in. It takes thousands of years to happen, but this country is getting larger. That's it for the notes. Make sure you ask any questions that you have.